In December of 2019, I replaced the walkway in the front of my house. When the time came to decide on walkway lamps, I decided on the Hue Calla Ballard lamps. They were attractive and fit in with the rest of the light schemes in my home. I built nice redwood platforms for them and did the installation myself. They made me happy. What could possibly go wrong? After all, Hue Philips is a real company. Well, flash forward to the summer of 2021, and I noticed something was very wrong. The Callas were yellowing. Hue's bizarre decision to use ABS plastic without UV protection instead of frosted glass meant that there was no chance at all that these lamps would not yellow over time. Contacting Hue's support line led to a series of red flag questions. Were these installed outside? How much sunlight do they get? Hue, clearly, had not thought through the problems inherent with using ABS plastic on $140 outdoor lamps. Time to once again re-engineer an existing product that was almost right the first time. By the way, any products that I mentioned in the making of this video, I'll include the links in the YouTube comments section down below, so you don't have to take notes. Okay, so this is a malfunctioning Hue Calla that I've had for a while. It legitimately broke, which is actually kind of convenient because it gives me a chance to play with it just in general. The yellowing of the ABS plastic and the general makeup and survivability of the light itself. The top here is a little screwed up because of me. I was messing around with the top with various chemicals and buffers, and it's not normally like that. So I've basically used the RETROBRIGHT recipe on the ABS, which has actually worked really well. Like if you look at some of my other Imager accounts, you'll see how incredibly yellow these things have gotten in just one season. So it's a little weird and embarrassing for Hue to have made a very expensive Ballard light that doesn't have a glass top. I don't understand why they didn't do that, especially when you look at this. So this thing is a low voltage, just straight up LED light from a company called LeonLite, Leonlite. You can find these on Amazon. The Hue Calla Ballard is between 125 and 140, depending on if you get it with the power adapter or not. This little sucker is $75 for 4 or 10 for 150. So basically, for the cost of a Hue light, you can get 10 of these. And you can't tell this in a video, but this thing is well made. When you pick up the Hue, I've taken the bottom off, so I gotta be a little careful. When you pick up the Hue, it feels cheap. It feels very low cost. The metal body itself is problematic. It's metal. It's not rust-free metal. It's not going to go anywhere. The ABS plastic makes it feel even more cheap. This sucker, which is literally, again, I gotta say, 1/10 the cost of this, has frosted glass top, very solid metal exterior, nicely sealed at the top, and nicely sealed at the bottom as well. As a matter of fact, it's so well sealed, I'm not sure I can do this little experiment here, but I'm going to give it a shot anyway. You'll see the Ballards aren't quite the same size. The LeonLite is just a little bit smaller in diameter and just a tiny bit taller. Not too bad, though. Anyway, so I'm going to do some experimentation with this one since it's all beat up. I'm going to see how hard it's going to be to remove the actual Hue light guts from this Ballard and see if I can transfer it to this Ballard. If I can get that done, then I'll have a Hue light in the body that should have come with the Hue Calla to begin with. So I hope you're paying attention, Hue, because you've really, really messed up. I don't understand this. All the other Hue outdoor lights, the ones for the side of the house and some of the other groundskeeping lights, they have glass. They're all glass. This is exactly what it sounds like. It's the same crap that you make beach chairs out of. It's just ABS plastic. And again, this guy is solid glass. So anyway, so that's where we are, and let's see what happens. Okay, so I've opened up the Calla. It was actually as easy as I thought it might be, but it also opened up in a way that I was not expecting. So inside the Calla's tube, there were 3 spot welds, and they were not solders, they were welds. So I didn't have a welding machine, so I used my trusty Dremel tool to cut through the weld. So I cut those through. And I expected this metal plate to pull out this direction through the tube, but that's not what happened. What happened when I broke those welds is the entire top section, which is one piece, which I guess makes sense because it's sealed for weather protection, came out in that direction. So it basically popped the top off. It wasn't quite that easy. I had to use a hammer and a chisel to push it through, but it did push through. This piece here, which is the decorative front plate on the front of the Calla, if you flip it around, it acts as a lock. So when this front part came through, this lock was here, and I think that was simply keeping tension on the inside until the welds could take place. So at any rate, so here we are. So we've got a Calla that has been deconstructed. So the base, the metal tube, the chassis, I guess, the locking mechanism for holding in the actual components of the Calla, which is here, and now I'm going to take this apart. So stay tuned. Okay, I succeeded in getting the ABS plastic top of the Calla off. There were like 4 little tabs that were connecting it to the solid plastic chassis. I could not push these tabs in. It's made to go one way, so once the top is on, it can never come off. They designed it that way. So I had to destructively remove it. So I snapped the plastic for the tabs, which is fine because I'm never using this thing again. So I pulled the top off. There was this rubber sealant gasket, which is great. And then what I was hoping to see, which is here's the LED array, and it's connected to the smarts through this bus that goes into the guts inside the chassis. And what I was excited about when I opened this up was my fear was that this entire chassis would be necessary. And the problem with that is in the LeonLite, what will hopefully be the new chassis for this thing, the barrel diameter of the Ballard is less than the diameter of this chassis. So there would be no way to get this inside of there. So this looks very disassemblable. So I'm going to pull this apart and see what we got. Okay, voila. This crown assembly, which is made of probably aluminum, just unscrewed. The bus, which plugged into here, just slipped off like any other bus, and that's it. So all that's left in this chassis now is the Wi-Fi, or I guess it's the Zigbee chip, and the connections between the logic of the LED lamp, the Zigbee radio, and then the bus that connects it to the LEDs for getting commands from the hub. So next step is to take off this little daughter board. So once that's off, this is a very small little assembly, which is really great to see. So retrofitting it into here should not be an issue. I'm concerned about what it's going to take to actually open this one up in a non-destructive manner, but we'll see what I can do. These are so cheap that I don't really care. I bought the pack of 4, so if I fail on this one, I've got 3 more I can try with. Again, significantly less than the price of the Calla, so it's fine if I lose a few in the process. At least I'll learn some stuff. Anyway, back in a minute. Okay, the disassembly of the Calla is complete. The final step was getting this daughter board off of that wire so it could come out of the chassis without destroying this chassis. So this is almost a completely 100% destruction-free disassembly, except for the 3 welds I had to saw through, and then the snapping I had to make on this piece here. But if I ever wanted to put the cap back on, look how yellow that is. Jeez. If I want to put the cap back on, I could super glue this thing or something, but it's never going to happen anyway. Be careful when you do this, because the power goes to this little trap here on the daughter board. And if you're familiar with screwing around with laptops, you'll have seen this kind of thing before. If you aren't, this will scare the bejesus out of you. But this little thing is essentially a wire holder. So the black hot wire goes on the right, and the red return wire goes on the left. And then those 2 little hatches snap down. And in order to do that, again, non-destructively, you'll need some equipment like these tweezers. I've got a nice little kit here from ORIA I've had for decades. That actually works really well. So nice little IC removal parts if you tinker with this stuff a lot. So okay, so it's completely disassembled, and I'm very happy with this arrangement. I can take the LED panel off if I want, or leave it on here. The next step is a little frightening, which is trying to get into this monster, which has no visible means of egress. So we'll see how this works out. I might destroy 1 or 2 of these to figure out how to get into one of them. The end goal here is to get these components into this LeonLite, and then plug it in and see if I can control it with the Hue controller, which I should be able to do if I haven't destroyed anything in the process. And if that is doable, this is maybe a half-hour operation per light to put the Calla in the guts of a Ballard that it should have been in the first place. Hue, geez. All right, let's see what happens. Okay, so on to the next stage of this, which is disassembling this LeonLite. As I noted earlier, this is extremely well constructed compared to the Hue. It has a solid metal chassis. It has a frosted glass top, and then it's a low voltage light, so it just has the cabling coming out, and no visible means of entrance. So because it's so well made, getting into here is going to be a troublesome thing. But the plus side is, because these are so inexpensive, I don't care if I waste a few of them trying to figure out how to get in. I got 4 of them for 75 bucks. So started experimenting. So my first attempt here was to pull the glass cap off. I figured that this was a rubber gasket, or at least the plastic external extremity to a rubber gasket, and something similar going on the bottom. So I tried giving it a pull, and this actually loosened up a bit, and that made me feel pretty good about, okay, well, that's the way in. So I started screwing around with unscrewing the top, and no joy there at all. And then both this ring and the ring at the bottom, it's impossible to unscrew because of these indentations that they made for both the cabling here and here for some sort of exact placement of this ring. I suspect that's what this is for. So none of this spins. So this entire thing, as opposed to the Hue, is perfectly sealed. There's no way in. So it's not meant to be user serviceable. So I did what every good home tinkerer would do, is I took a hammer to the top. This is the disassembled LeonLite. My thought was that getting through the top would have been possible through unscrewing the glass fixture. So I took a hammer to the thing, shattered the glass fixture. Not the case. So this is one remaining piece of the glass. You can see it's got a ridge in here that is not a threaded ridge, that is meant to fit into whatever this gasket is. And whatever that gasket is turned out to be a solid piece of plastic. Now, what was interesting when I pulled this out, and we'll come back to this later, is, I'm not sure you can see it on here because it's black on black, but there's black silicone rubber used to seal this thing in. So both the top and the bottom of this lamp are very tight, looks like PVC or ABS plastic, probably PVC, ring that has nice little indentations that I think you can see there in the light, that makes a snug fit when placed into here. Like I can't even, you have to push it to get it to go back in. And then they used rubber silicone to seal it for the waterproofing. And that's great for these lights. They're never going to fracture. They're never going to have problems. There's no screws or eyelets for any water to get into. And it also makes it impossible to pull these things apart. So that's kind of a drag. The positive side here is that once you are in, the setup for the LED array, which is just a cheap white LED array, because remember this is a low voltage light. It just does cool white. So that's what this is. The setup for the LED array, very similar to what the Hue had. It's a disc with the LEDs on it that fit right into here, right? And they broadcast up out of this cone and light up the glass. And because the arrangement is so similar to what the Hue had, let me just get it here and I can remind you. Hopefully I can find it. I don't have it where I can easily bring it out, but the Hue LED disc is roughly the same size and shape. It also has a daughter board here, which is a lot less complicated because there's no Zigbee or Wi-Fi chip or anything on here. This is just take in the circuit, generate a current, and light up the LEDs. So replacing the mechanics on this thing is going to be very, very simple. Taking it apart without destroying it is going to be hard. Now, I have a couple ideas. I'll let you know how these ideas work out. I'm going to leave the top alone. The top is nicely sealed. The LED panel, the LED disc that I was talking about just a second ago, is actually attached to the broadcast cone from below. So if I can get the bottom off in one piece, or a one piece repairable, I can just go in through the chassis with a long screwdriver and start dismantling it, and then put the new elements in place, and this should be nice and you know, untouched, basically. So how am I going to do that? I tried a couple different things. If I use a hairdryer on the outside of this, at the bottom, it does loosen up the silicone gel that's holding it in place, the silicone rubber that's holding it in place. But you can't get a grip on this thing to pull it out. It does have this threaded insert for a ground stake, right? That does screw into the top here. There we go. So, but it doesn't provide enough of a grip for me to give this thing a good firm tug. So what I'm going to try is, in that recessed area for that threaded ground stake, I'm going to drill a hole. And then I am going to get one of these a little bit of a larger version of a butterfly anchor. And I'm going to insert the butterfly anchor through this hole, make a nice little handle for this thing out of some wood, and see if I can make a system where I can grab and pull this bottom. So I will heat up the outside of the chassis with a hairdryer, which will, I hope, soften the black silicone rubber. And with that handle I have created, give this thing a tug, and firm tug, and see if I can pull out the bottom, which I expect is set up exactly like the top was, which is just a piece of PVC plastic with these ridges to help hold it tight into the tube, and the silicone application there will be loosened. And so if I can do that and pull that out in one piece, I'm golden. Okay, so moving on. I used the Ballard that I broke the top off of to try and figure out how to get the bottom off. Turns out that both the top and the bottom, as I mentioned before, are basically glued in place with that rubber insulating epoxy. I think it's rubber silicone. So to get this off in one piece, it took some brute forcing. So what I did is I made a little tool. I made this guy. Isn't that classic? I used basically a heavy drywall anchor. Right. Got these nice little alligator clips here that flip down. And I made a little handle of wood so I can grab onto it. And then I drilled out the center hole, which is the hole that is used to position the stake in the floor, in the ground, sorry. Right, so this goes in the top, screwed it, good. That hole's exactly 5/8 of an inch. So I drilled that out, stuck in my makeshift, wherever it went, stuck in my makeshift handle, right, and put that handle into a vise that I've got screwed into the table. I then went over the outside of the Calla with a hairdryer to get it nice and warm, and then started to apply pressure by pulling the Calla that way with the handle locked in place inside of this guy. This will work better if you've got two people, but my second person in the house is a dog, so he's not going to be much help. I then used a discarded wood chisel, and I used one that you don't want anymore because this will ruin it, and just very slowly went around the edge of the hot Calla, the hot Ballard, and simultaneously pulled and used the chisel to pry up. So I did that on the test unit, and it got pretty banged up on the outside. So when I used the real unit here, I did the same procedure. I was just a lot more careful. You can see the edge is still really chipped, but the chipping isn't that bad. And I can sand this down and then repaint it once I'm done. But so I got inside, and using a long screwdriver, I pulled out all the guts the same way I did for my test Ballard. Right? It's probably out of focus, but sorry. So probably the same way I did for the test Ballard. And I got the insides out. So that's it. So now I'm in. Now what's interesting is this is the LED from the original Hue Calla. What's interesting here is that it fits perfectly. If I just shove this thing all the way down, it will shove up against this guy, this framing, which is at the very bottom, or I guess the top of the Ballard. And I'm off to the races. So I'm going to do that, put this all together, and I'll be back in a second. Okay, the Hue LED lamp is in the chassis for this bad boy. The mechanics, the daughter board, are just kind of floating there. This is still just a test unit. I think for the final unit, I'm going to figure out a way to anchor it so it doesn't quite float around like that. But I don't think for this unit it really matters too much. What I did on the base, by the way, here's the base from the ruined unit, is I drilled a hole which is the same size of the hole on the original Hue Calla opening in the base. So that allowed me to use the same gasket that they used for sealing. Sorry, everything's black, so it's really hard to see. And it fit in perfectly. So that's sealed up. All that's left is that hole that I made to drill into to use the butterfly handle, essentially, to pull this thing out. So what I'll do once this is done is I'll silicone that together, or sealed, so it's nice and tight. And then that will still give me the screw-in base from the new Ballard, which should work just fine. So I'm going to put this all together and we'll see what happens. Okay, the Hue Calla LeonLite hybrid monster thing is done. I used silicon sealant at the bottom. So it's sealed nice and watertight the way that it used to be. The bottom got pretty chipped up when I pried the bottom off the original unit. So, or the first unit. But I can, again, when I put these in production in the front yard, I will sand that down and just repaint it with a nice black paint, and nobody's going to really notice. You know what's nice here is that the LeonLite Ballard, the LeonLite Ballard has this nice little notch that perfectly fits the Hue cable. So we'll plug this in, we'll see if it works, and if it does, then we have a Hue light with a properly constructed $15 Ballard with a nice glass top. Okay, so I did some finishing touches here just before testing it out. I painted the bottom. Well, I sanded and painted the bottom. I grabbed some Rust-Oleum paint, which I thought was flat black, but I think it's matte black. I'm sorry, gloss black. So I will redo that at some point when I get a chance. And then the other thing I did is the center hole here that I drilled out in the base. This one, not that one. I found that number 0 stoppers. This is a white one. I've used black. Number 0 stoppers, which are 1 inch long and just over 5/8 inch at the top, and I forgot how much they are at the bottom, will fit perfectly into this hole. And so I put a little silicone gel on there, or silicone sealant on there, shoved it in. And this stopper's black so you can't see it, but it makes a nice seal. So this thing is now 100% sealed for outdoor use. So let's do the moment of truth here. Actually, it's a moment of truth only for you watching on the video. I've already checked to make sure this works so I don't make an idiot of myself on the video. But let's plug in. This is a standard Hue adapter for the Callas. Plug it in and look at that beautiful thing. Isn't that nice? I have it on the Hue app already as test Franken Ballard. So on, off, right, and I can adjust the color. Look at that. How gorgeous is that? You're getting scan lines on the video, but there are no scan lines in person here, so. So there you have it. It is a complete little goodie from the lab of Rob here. It's nothing to do with any company at all. So again, it's the LeonLite gutted out and filled with the Hue Calla guts, and I can't wait to get these in the yard. I don't know if you remember at the start of the video, I apologize because the video was so long, but I thought it was best if everyone knew it. The problem with this specific Calla, and the reason I'm using it as a test, is I'm unable to control the power for some ridiculous reason. Something blew out inside of it, and so there's no real power adjustment on this anymore. It's on or off, and that's it. Actually, it doesn't even go off, so it just stays on the whole time. But this is the functionality it had before I did the brain transplant. It's a beautiful light now. Not that the Calla wasn't beautiful, but this will be beautiful in 10 years, where the Calla would probably turn a nice piss yellow by the end of that 10 years. But there you go. So that's it. I'll have additional videos as I start to replace all the lights in the front yard with this particular little goodie. And I'll show any problems I've been having. I also want to do an explainer video wrap up to kind of talk about things that I wish I had done in the process of putting this together but did not do. So thanks for your patience. Again, I apologize for this being so long. It was just easier to show you as I was doing it than to just do a write-up at the end, but I suppose I can do that too. Take care, Internet. Talk to y'all later. Sorry for the annoying buzzing in the last section there. I think something was running in my shop. I'll redo the audio when I get a chance. I just wanted to thank everybody that made it all the way through to the end. I apologize that this took so long. I just felt like it made more sense for everyone to see everything that happened every step of the way. As I said earlier, I will put all of the links to all of the products that I used in the show notes. And I just wanted to say that if Hue is listening, what were you thinking? I'm really curious. Like, it doesn't make any sense that you put a product like that at that price point into the public market. So, you know, I can fix it because I'm tenacious about this stuff and I've got a tremendous amount of OCD, but not everybody's going to do that. And when you're charging $140, $125 for a product, you have to do it right. You did it right for all of your other outdoor products. Why did you do anything different with this one? I don't understand. And I'm not sure anybody else understands either. So that's all the ranting I'm going to do. Again, apologies for the length of the video. I'll do a couple of follow-up videos to this going forward that show all 10 of the units being replaced. And things I would have done differently the first time around. So thanks a lot. Have a great day, everybody. See you.